That's very true, Gary T. Welcome in, welcome in. How are you doing? Oh, my word. All right. So we're going to be getting on with hopefully getting a board etched tonight. But we shall see. We shall see whether or not we can dial things in. So I'm going to be demonstrating a few things tonight, as well as trying to get this circuit board done. So okay. So we're just going to give it until the hour, and then we will make a start, I think. So this is, I need to get some background audio sorted out for this sort of starting stream scene, just as a bit of a chill, because it's quite quiet at this point. Okay. But you are right. It's better to kick the tires than the tires kick you. 100% agree with that sentiment. How is Tuesday treating you? I hope you're doing well. You've got to put some bits and pieces out of the way because we could get messy tonight. We're hopefully going to be breaking out the nasty chemicals and etching a circuit board. So we're certainly going to be breaking out some nasty chemicals in order to do some preparation work. But we'll cover that in a second. Okay. Okay, hopefully the audio is a little bit better than last night, but right, here we go. Let's go for this. And welcome back to part 2 of making circuit boards from home again. So just to recap, we did a live stream whereby we attempted to treat a standard piece of copper-clad circuit board to make it photosensitive and then use a resin-based 3D printer to expose the traces that we want to keep. And then the intention was to etch that circuit board and get everything ready for the next phase of the project, which is ground testing. Good to see that the audio is great. Thank you, Gary T. Appreciate you, buddy. So where did we get to last night? So last night we did the exposure, and we got to a state where things were a little bit overexposed. So these copper traces actually broke free, and we can actually get down to the copper, whereas these ones here, they've actually got the photosensitive coating on them, and they don't, you know, they won't etch at all, right? So see if I can show you that. It's trying to get that into a good contrast position. There we go. So you've got the circuit board there. But the problem you've got is those traces. The isolation from the ground plane is pretty poor, so that didn't work. So what are we going to do? All right, so there's a positive side to this. It means that we've reached the upper level of exposure. We've been able to overexpose the treatment that we put on the circuit board. meaning we just need to dial it back in order to get that sweet spot exposure. Now, I'm going to guesstimate that exposure spot. I think we were in about the region of 20 to 25 minutes exposure time to cause this overexposure. So what we're going to do tonight is to dial that back to around 18 minutes, and hopefully that will be sufficient amount of time for us to get good isolation of the traces, but equally we get that separation layer from the ground plane, because we don't want these traces too short to the ground plane. Again, to highlight, as I did yesterday, this is an experiment, so there's every opportunity for this to go bad. But at the end of the day, when things don't go the way you hope, you either win or you learn. So we could be doing some learning tonight as opposed to winning. But whatever way you want to spin that. So let's get right into this, because we know the time is cooking, right? So we've got a couple of cardboard that we now got this overexposed material on, and we need to remove it. So last night I was using sandpaper to get this off because I couldn't find the right materials. I've subsequently found the right materials. So we're going to use some water and some lye, caustic soda, NaOH, sodium hydroxide, whatever you want to call it. We're going to use that, dilute that into some water, and then we're going to place the board into the bath. And essentially this material is acid resistant, but it's not alkaline resistant. So when you put it in an alkaline bath, it will dissolve this material and off it comes. So let's get into that. Right, so I've labeled a couple of pots here so that we don't mix them up, because the color of these liquids are potentially going to look very, very similar. So we're going to crack on. This is backwards. It's NaOH I wrote on the bottom, and then I turned it over, it's backwards. But at least I know what it is. So I'm going to pour out some just regular tap water into this tray. And then I'm going to get some caustic soda. In the UK, it's called caustic soda. It's a drain cleaner. And in America, I believe it's called lye. It's sodium hydroxide. NaOH is the chemical formula for it. And it has many, 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 many uses. It is a very versatile product. It can be used for... Well, damn, you can make it. You can use it for making soap. You can use it to, clean drains. You can. There's other processes which I'm not going to talk about on YouTube, because I don't know how YouTube would particularly view them. It's perfectly legal, but I don't. There are certain things on YouTube that YouTube doesn't like, which I totally get. So I'm not going to go that route. But if you're in my Discord already, give me a yell and I'll tell you what I mean. All right, let's take my watch off because we don't want to get any lye on my watch. Right, stretch, big stretch. Okay, so here we go. So we're going to use this max strength caustic soda, and we're going to pop it into the liquid. You should always add caustic soda to the liquid, not the other way around, because otherwise you can get an unexpected reaction. Yeah, so don't do that. So all I'm going to do is just crack this open. I'm going to put it over the top of here. There's always a few little crusty crystals that drop. So get that over the water, and then we're just going to measure out a small amount of these crystals, these like little balls, into the water, and they start to dissolve, whereby we put the lid back on over the water so any crumbs Go back in, we lock off the bottle, and we put this away. And we're going to keep our gloves on because this stuff is caustic. That's why it's called caustic soda. Essentially, if you get this on your hands and you get your hands wet, which often skin is very moist anyway, right? What happens is you get like this slippery texture to your hands. And what you're actually feeling is the caustic soda turning the fats and oils on your skin into soap. So it's effectively turning you into soap at that point. So that's not a good thing. Caustic soda burns are not pleasant. They can be very painful. So don't mess around. I wouldn't necessarily say that I followed the best safety protocols. I'm comfortable working the way that I'm working. However, I'd like you to do your own research, because it's I'm not going to have you come back and say, oh, Steve did this, it's his fault. No. I told you to do your own research. All right, so what I'm going to do is I'm going to switch over to this side camera, and we're going to get a side view of, in fact, we see if we can get an over-the-top view of this process. This is actually really interesting to watch when you see it go off. It's pretty cool. So I'm going to pop the circuit board into this solution, and what you'll see over a period of time, you'll start to see this. I mean, this stuff is on there, right? I'm not going to touch the screen of my camera, but this stuff is on there. It's not going to come off. But watch what happens when I pop it into this liquid. So in it goes, and then the caustic soda starts to react with the coating that we put on. And in a few moments, we're actually going to see it crinkle and start to bubble and like lift off of the circuit board. So all of that sanding that we did yesterday didn't really need to do. So I'm going to get the spoon. I'm just going to agitate this in the liquid just to make sure we don't get like a layer, an isolation layer around the surface. And it will start to bubble, hopefully not, but in not a very long space of time. Let's get you a good view, shall we? Where do I want you? I want you by there. And let's tilt you like that. Okay, I think we can start to see it crinkling. There it goes, it's lifting. Wow, would you look at that? And then off it comes. All of that effort that we had yesterday to clean that board, and all we need to do was to dunk it in some lye, into some solution, and off that comes. Pretty cool, no? Okay, so what we're going to do now is we're going to put that to one side, and we're going to get another pot, and in this pot we're going to put some water. Just plain tap water again. Same old plain tap water. And what we're going to do is we're going to fish out our circuit board. And we are going to drop it into the water. Just give that a bit of a swish. It feels like a cooking channel all of a sudden, right? Give it a bit of a swish. Just to rinse off the lye, dilute it. So when we do get to handle this, it's not so much of a problem handling it. Okay. Let's get the spoon in there. Let's get a fresh piece of towel. Let's dig out the board, and we're going to dry it off. And then we're going to go through that whole cycle of prepping the board ready for processing. So I've already gone ahead and sliced the file. I've extruded the file to, I think it's around 3.6 millimeters. I've given the file a 15-second exposure time per layer on all layers, and ultimately that should yield us a total exposure time of around 18 minutes. But that will the print time will take around about 20 minutes to fully expose the board, because it's got to go through the cycle. I've limited to 15 seconds with a 2-second break, because I don't know if you recall yesterday, I was a little bit concerned about running the LED, the UV LED in the printer continuously too long. So the idea is that we give that a bit of a break, and give it time to cool down, so we don't burn out that UV LED. So what we're going to do, we're going to take these containers out of the way now. So this is the caustic soda solution, and we're going to put this somewhere where we cannot hit it, knock it, bump it, all the things. So let's put it on the bench here, and if nobody goes near it, nothing bad can happen, right? Right? Famous last words. Water, just plain water. This is more of an annoyance if I tip it on the floor, so I'm not overly concerned about that. We will hopefully be breaking out the 3rd and 4th baths. The 3rd bath is for exposure. The 4th bath is going to be etching. So we're going to try and expose this circuit board, develop it, and then etch it. So at the end of the stream, we should hopefully have a circuit board which is ready for solder mask and ready for the holes to be drilled for the components that we're going to be popping on the board. So just in case you missed yesterday's live stream, we are making a breakout board for a test phase of a project. We have a piece of equipment which we need to interface with. We're not quite sure how to drive it. So this interface board is going to allow us to probe this device with low-level logic. We'll be able to test voltages. We'll be able to put an oscilloscope on it to see what signals are coming back. We can do all the things. And essentially, that's going to allow us to push that project to the next level. And we're building a singular circuit board. We could have gone and have this made by a board manufacturer, but that's a little bit excessive for what we require for this project. So if you were here yesterday, apologies for the repetition, but just for anyone watching on the VOD, catching this for the first time, or did not catch yesterday's stream and is here in chat, that's what we're working on. Feel free to ask any questions as I go along in today's stream. I'm more than happy to share and where I can demonstrate. And and if you're watching on the VOD, feel free to leave comments and questions down below. And I will get to those in due course. Right, so I've just given that a light sanding just to remove any oxidation that has built up since yesterday. We want this board to be as clean as we possibly can. And now I'm going to take some isopropanol alcohol and I'm going to clean the board down to make sure there is no oils or any debris remaining that could cause a problem when we put the UV coating on. So let's just give this a wipe. So this method I found was recently documented by a guy called Stephen Hawes. He is the founder of, I don't know if he's the sole founder or co-founder, I'm not quite sure, but he's the founder of the company Opulo. And Opulo is an open source company that make the Lumen P&P, the Lumen pick and place machine, a machine that I built here behind me, and I built it from source. I didn't buy a kit, but I did build it from the source files, which they make freely available. Right, I'm going to get the laminator warming up because we do need a paper laminator. that is required to get the UV coating on to the board permanently. And I am now going to just grab some supplies, and we're going to crack on. We're going to get this done. Get it done. Right, let's have a look at the cuts of the... I'm just looking at the spoiled parts of the material that I've got here. So the UV coating comes in on a blue roll. This is this material that I'm holding up to the light here, and I don't know if you can see. There is like a darker shadow on this material, and what's happened here is over time the light has leaked in to the roll, and it has actually cured some of this. So I'm going to be splicing this up and using it for other projects in the future, but I'm looking for a suitable piece. Franklin PMP, for real, Dimitri, for real. He's alive. He's alive. Right, let's cut a fresh piece of material, and we'll get this applied. The process is pretty simple. What we're trying to do, it's the execution that is problematic, right? Theoretically, right, I can tell you how an internal combustion engine works. That doesn't mean to say I can take an engine apart and put it back together and make it work, right? So the concept of what we're doing is pretty straightforward and simple, but the execution is the hard bit. Who knew? Who knew? Right, have we got any exposure on this piece that I've just cut off? I think we're actually pretty good here. So I'm going to use this piece that I just cut off, which I would have probably used as waste or for another project. I'm going to try and keep as much of this material as I can because it's really handy. I mean, so there's a number of different ways you can make a circuit board. The obvious and the cleanest way to do it is to design your board and get it sent out to a manufacturer, right? And have that done. Time is the major part of the process, right? Yeah. Don't mess with it, right? It is actually like cooking. The more you poke at your food while you're cooking it, the worse it's going to turn out. You've got to just submit to the process. Submit to the process. So yeah, you could go out and have you design your circuit board in your CAD program of choice. I prefer to use KiCAD. This is where we get fun, right? Because we're going to start playing with like nitrile gloves and sellotape, sticky tape. So you can do that. You could etch your own circuit board using the various different methods, this being one of them, or you could use a CNC machine to mill the circuit board. And there's pros and cons. People have certain things available to them that others don't. So I was very intrigued when I saw Stephen Hawes demonstrate this particular method. He had all sorts of issues with his setup because he was using a modern resin-based printer, and he had to hack away at the firmware. Oh, there we go. I got a bit of sticky tape stuck to my glove. He had to hack away at the firmware of the printer. There was a bunch of things that he had to hack about with to make it work. Whereas with the printer that I'm using, which is the Anycubic Photon S, it's a little bit low-fi by comparison, because I don't have a door sensor, I don't have a resin ultrasonic sensor. There's lots of safety features and quality of life features that my printer doesn't have. So I don't have to work around them. So anyway, so we cut the UV sensitive material. we have now placed it onto the circuit board, and what we're going to do now is we're just going to try and get this as flat as possible onto the circuit board and try to remove all the bubbles that we can see. A bubble-free application is desirable. Okay. How's your evening going, Dimitri? Hope you're doing well, buddy. Thanks for popping in. Okay, there is a little bit of a wrinkle there, so I want to see if I can get that out. Okay, done. All right, so now we need to put this into a makeshift protector, which we're using just a regular piece of copy paper here, folding it top to bottom, and then we're going to place this board inside like so, and I'm going to just close the lid like that. Close the lid. What am I talking about? And then we're going to get a paper laminator, just an A4 laminating machine. And we're going to run this through the laminating machine once. And what happens is that the UV sensitive material heats up and bonds to the copper surface. So this is where we were talking about we want as fewer bubbles in this as possible. We want a nice, clean application. So fingers crossed, we can get the application done nice and clean the board up, and then we can expose it using the UV resin printer. And at the end of the process, in about 20 minutes time, we should hopefully have an exposed board that we're going to get ready, develop, and etch. That's going to be kind of cool. So I kind of avoid doing the etching. My normal go-to is to go out to a circuit board manufacturer and have my boards made. And the simple reason is you know, the cost of these things is quite cheap, and the thing that gets you with PCBs manufacturing is the cost of shipping. That's the only kind of downer. Cost of shipping and the time that it takes for some of your parts to turn up. Now, in most cases, a board manufacturing house will be absolutely fine, simply because you know, it's a hobby type of thing, or you're doing something with a bit of a lead time. You know you need something, you know it takes X amount of time, so you plan in that lead time so you get your stuff delivered to you when you need it. The beauty of being able to do this by hand is we're already, how long are we into the stream? We're 30 minutes into the stream, and we're already at the point of exposing the circuit board. So the reality is, within an hour to an hour and a half, we could potentially have a circuit board that we could use. And if it was all, I mean, these are through-hole components, but if these were surface mount, the reality is you could probably get this up and running and have components soldered to the board within 2 hours, right? So for rapid prototyping setup, that's going to be pretty dang cool, right? So let's switch over to the printer. So there we go. There's the all-elusive Anycubic Photon S. And we have a 3D printed jig, which sits in place of the resin bath, and that's locked into place. So we have a place to register our circuit board. I have put a little dot on the bottom corner of my circuit board so that I can place it on top of the screen, and we can expose this board, and hopefully, with any luck, in about 20 minutes time, we can have a working, well, we'll be ready to actually etch the darn thing. But we'll see. We thought we would be in this position yesterday, and here we are today having another stab at it. So, so just to be clear, I've used the. I'll explain the process of what we've done while this is printing. But I have set the layer height. I have set the duration and exposure times for the liquid resin, the virtual resin, right? So that we get a 18 minutes exposure. And it's because of the time off for the LED, this is going to take about 20 minutes. So we'll do a bit of a Q&A session while this is going. So let's go ahead and start that process. Off it goes. This head's going to drop. It's going to do its regular printing routine, and then it's going to turn the LED on, and it's going to expose. Rather than print resin, it's going to expose the circuit board in terms of its tracks and traces. Right. Okay, so that's off on its journey. So fingers crossed in about 20 minutes time, that is going to complete, and it is going to yield us a usable circuit. Now, if this fails, I do have another option open to me, and that would be to completely remove the ground plane that we've got on here. That means that the etch time is going to be increased, but I'm reasonably confident the separation in my traces is sufficient enough for us to be able to get a good exposure. It could be that the ground plane is a little bit close, and we don't want traces shorting to the ground plane unnecessarily. If they're data lines, that's no big deal. But if it's voltage, we've got 3.3, 5 volt, 12 volt, and we've also got 40 volts that is going to be spat out onto this board, depending on how we interface with the device, right? And the reason I'm being a little bit elusive is that it's a project for a buddy of mine, and if it was my project, I'd be telling you everything about it. But since it's not, then I need to keep that a little bit under wraps. But I can talk about the prototyping process, right? What have we done to get here? So there are a couple of different tools that I have used in order to create the circuit board. The first application that I used was KiCAD. And KiCAD is an electronic CAD program that you can design a schematic. A schematic essentially is just a map of the components that you're going to use in your electronic project, and it describes how those components connect together. They can look quite complicated, but once you understand the symbols and you understand how things connect and how they don't connect, and that if you've done any work with electronics, you know what I mean. Certainly when it comes to like traces in a schematic, if they cross, if you've got a line from a component, it goes off to one way, and you get a line coming across the other way, they're not connected unless there is a circle dot on that intersection to signify the connection. So yeah, that's the kicker there. So I'm just going to fire up KiCAD, and I will show you some of the bits and pieces where I can. All right, so if I just bring this down here. Oh my word, this window has totally resized itself to something which is completely and utterly horrific. Come on. There we go. So I'm gonna show this like this. I'm gonna cut the top of the screen off, which is fine. Right, okay. So this is what's called a schematic. And essentially, this just shows us a couple of different, in fact, two components, right? It shows us a connector, or in fact, they're two connectors. And then we've got our voltages and all of the different pinouts, etc. Right? So this pinout, this connector connects to this connector, and it's really hilarious that the J1, the first connector, the 30 pin, is actually smaller than J2, even though on the schematic that it doesn't look like that is the case. But I'll show you the physical components that we're working with shortly. As I mentioned, if I come down here, this is what I was talking about. When the wires go across, you'll see there are circles. These circles represent where the traces are connected, and where there are no circles, they're not connected. So electrically, these are isolated. So that can throw you, especially when you've got this is like an incredibly simple circuit, right? But that sort of stuff can throw you. And all I've done is I created labels on here so that the routing of the wires is a little bit nicer. So I use a label at the end of the wire on this side, and I just put a label on the end of this wire corresponding to each side, and that just defines how these two things are connecting. The next thing you need to do is to associate a footprint. All a footprint is what does pads look like that this component uses physically? If you were to draw them, what do they look like? So you have to assign that for each component. Now, we've got two components. So this took all of about 10 minutes, if that, to find the right component in a library, a huge library that KiCAD carries, to assign them. And then that allows you to move on to the next step, which is to create the circuit board. So one of the questions I get asked is, why don't I use Fusion 360 when it comes to doing circuit board designs? And there are two main reasons that I don't use Fusion 360. The first of which is when I first used Fusion for this, they recently integrated the Eagle CAD program. Eagle is another application like KiCAD that's used for designing circuit boards. And they integrated it into Fusion 360. And the user interface was horrific, to say the least. Looking through the window of Eagle, you were designing your circuit board in a window this big, and you had loads of menus. And I'm sure they've revised it. This was going probably about 10 years now, or the best part of 10 years ago, when that was initially integrated into Fusion 360. The second reason I don't use Fusion 360 is I don't have a full license of Fusion 360. I have the personal license. So along with the restrictions of only having 10 active projects on the go in a read-write state, and all of the other constraints that a personal license applies to the user, you can't use it for commercial use. I believe there's around about $1,000 limit that if you make money over $1,000, they expect you to pay for a license. Which, if you're making money off Fusion 360, then yeah, I kind of get it. You know, they still got to keep the lights on. They still got to pay their employees, and they got to, you know, they're a business at the end of the day, right? It's not charity. So the fact that they offer a personal license for hobbyists, for makers, etc., I think is amazing, and it is a little bit of a thin end of the wedge trying to get people into using Fusion 360. But arguably, you could use that tool to learn Fusion 360 to a point where, I don't know, you could change your career, and you could go on and go work for a company that uses Fusion 360 in their workflow, and you just slot in because you've had free access to it. But anyway, that's by the by. If I wanted to design a circuit that I want to sell, then that license is a bit of a hazard for me in that regard. So those are the two main reasons. Maybe I should revisit Fusion 360's PCB edit, creation tool workflow to see how it's changed in the last 6 to 10 years from when it was Eagle. Yeah, it's the UI, legacy UI, and the license, which is why I like KiCAD. KiCAD is open source. It's multi-platform. If I want to run this on Linux, I can, and off I go. It runs on Linux, Windows, Mac. So yeah, all the heavy-hitting operating systems. KiCAD is available for Fusion 360. It's only available for Windows. So yeah, that's a bit of a pain in my workflow. The next thing that we need to do once we have created our schematic, that is to do a board layout. And I'm padding for time, right? I'm padding while the machine is exposing our circuit board. So if anybody has any specific questions and wants an overview of something, please feel free to ask away. I'm more than happy to cover that. Rather than me just rambling to some extent. Okay, so we're going to load up the board editor. So this is the board editor, and we import our circuit board schematic into the board editor, and we then create a layout. So this is where we physically draw the traces from each pin of the connector to the other. So this is the big 30 pin that we saw in the schematic, and this is the small 12 pin that we saw in the schematic. It's kind of funny, right? And these are the real life components that we're using. So we're using a screw terminal. So this is for easy access to each of the pins of the device that we're going to be interfacing with. And I can just use the screw terminals and hook up another controller, an Arduino, an oscilloscope, a multimeter, whatever I need, right? So once we have that available to us, all right, we can get on and get into the project. But this is the 30-pin connector. It's a FPC, or a flat cable connector. The pitch on these pins, I don't know if you can make that out. The pitch on these pins is 1 millimeter. They are staggered, so each row is about 2 millimeters apart. So yeah, it's not the finest pitch that I've ever worked with, but I mean, from an exposing a PCB's perspective, this is this is getting close to some of the fine work that you might need if you use like an SMD, a surface mount chip or something like that. So you then design your circuit board. You then output that as a Gerber file. These are manufacturing files for the circuit board, and essentially it's just a way of describing the physical product that you want the board manufacturer to make. Now, bearing in mind, we're looking top down onto the circuit board. We are looking through the top surface down to the bottom copper layer. The components will be on the top layer here as we see it. So we have to keep that in mind when it comes to processing further down the line. So once we've done this portion and we've exported our files, next up we need to process that into a format that Fusion 360 can understand. Now, there could be another way of doing it, but this is the way that I devised. I don't think I invented this method, but if I did, then that'd be cool. Just saying. I'm not going to say out the gates that I did invent this, because I highly doubt that I did. Right, so we're going to use an application called FlatCAM, and FlatCAM. So you may or may not be familiar with the terms CAD and CAM. So CAD is computer-aided design, and CAM is computer-aided manufacturing. So a CAM processor essentially into a language that a machine can understand. Now, I define the term machine quite loosely. It could be a CNC router. It could be a 3 to 5 axis CNC machine. It could be a 3D printer. Arguably, a slicing software could be considered CAM, right? Sorry, Steve. Hey, Ray, welcome in. The PCB design is triggering your OCD. What about my PCB is triggering your OCD? What is it? Okay, I'm going to open the Gerber files. I do need to navigate to a folder structure that has a naming convention, which will tell everybody what I'm working on. So I'm trying to be secretive about that. Sorry. Projects. Okay, so I've just imported the Gerber files that I outputted from the previous step, and we get this. Put, which is the edge cuts. We get the traces or the B.cu layer. We get the mask, and we get the silk screen. So if I just disable the plots, just so you can see each of these layers individually. Okay, so edge cuts. The edge cut defines no symmetry. Good. That's fine. I don't like symmetry. I don't like balance. There's no balance in my life. So all my projects need to be out of balance to be in balance with my life. so this curved, like this outer perimeter is defining the shape of the circuit board, right? Then the BCU layer, that's our copper traces. And these big green areas is the copper fills, and these lines are the traces from one pad to the next. If I turn that off and then I enable the mask, so this is the solder mask. So this defines where all my pads are. So we'll need to create an exposure layer that when we put our silk screen on, oh, sorry, no, it's not silk screen, our solder mask on, we expose it, and these sections then can be cleaned off with some IPA, and we get nice copper traces and a nice isolated pad. That's going to be really interesting to see whether or not I can pull that off. It's going to be interesting to see if I can pull this this exposure off. So anyway, and then finally, we've got our silk screen. So any text that we may want to put onto the board itself. So each one of these layers, I create an isolation layer. And what that will then do, what it thinks it's doing is it thinks it's talking to a CNC machine. So it's going to trace the outlines of all of these tracks. If I just outputted this from KiCAD as a SVG or a DXF file, each of these traces, apart from being fragmented because of the way KiCAD constructs the lines and what have you, it's a vector line. And when you bring that into Fusion 360, while Fusion 360 understands vectors, it doesn't understand the thickness of the line. So it doesn't know that these traces are about 1 to 1.5 millimeters across. It just shows a vector line, and a broken vector line at that. So that's not particularly helpful. When we do an isolation layer, this CAM processor traces each of the external lines that we choose for the particular layer. We can then export that to the DXF, and then Fusion 360 can manage it. Well, within reason. When I say manage it, it does have problems with it in the sense that there are lots and lots of dots or vertices along the vector lines. That causes calculation problems, but that's a whole new ballgame, right? So in order to create our isolation routing, what I do is just go into, let's have a look. Oh, edit. Is it edit? No. Tool, isolation. And then I could select, if I was running this on a CNC machine, I would go through it and define that I'm using a 40-degree V-bit, blah, 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 right? And I would effectively get the G code out of this processor to send to a CNC machine to mill this PCB as opposed to etch it. But we're not going to do that. We just want to generate the geometry right now. So you'll notice that I've created the geometry, and here it is. And I'll turn the other layers off when I've gone through all of this. So you do that for each and every piece of geometry that you want to export. So we've just done the bottom copper layer. We now need to do the mask. And then finally, we need to do the silk screen, just in case we want to use that. Isolation tool, generate geometry. Okay, so that's all the geometry done. So if I turn off all the plots for the Gerber files that we brought into FlatCAM, we now see all of these vector files that I can turn off, right? I can disable the plots for these, and you just isolate each one. So when I create the vector files, one of these is always turned on, and that's the edge cuts, because that will define the height and width of the job, meaning that when I take this into my 3D printing slicer, I can then center this consistently on the screen so that when we expose things, we have a perfect registration every single time. So how do we do through holes on this to use the back? Okay, so in theory, what you would do is you would follow the same process and export it, and you would export the top layer without rotation. You do have to, if you're talking about through holes, right, you obviously know about vias. So you then have to set up vias. And if you use a soldered component, like a through-hole component, to bridge the front and back sides, you could flood the hole and hope that it passes through the FR4 substrate, or whether or not you solder it from the other side. Depending on what type of component it is, you may or may not be able to get to the other side of the leg. So typically you would use some sort of rivet or something like that to solder. If it's a through-hole resistor, then you will be able to get to each side of the leg. But this FPC connector, you're not going to get to the other side of this FPC connector, right? You're not going to get to these inside pins. That's going to be such a challenge to try and get in there. So two-sided, you could artificially create a two-sided board by putting in large format 0 ohm resistors and route the traces underneath it, so you create like a bridge for those for the tracks. But I mean, flood the hole. That's why you're smarter than me. Yeah, you could flood the hole, but I think you probably would struggle with that depending on the size of the hole, because you don't have, so with commercially made boards, right? With commercially made boards, they are the inside of the hole is plated, and you can have solder on the wall of the FR4 where it's plated, so it bridges the front side to the back side of the circuit board relatively easily. Whereas with this FR4 that I'm using here, it's not so easy, right? So it's got to jump maybe 3 millimeters from the front side to the back side and hope that it tracks up the component leg to go through the other side, you know. But that's what that's the sort of physics that you're dealing with, right? You've asked the question, right? And chat replay is on. And if I dismiss that question, right, there could be somebody who's watching live in chat or watching the VOD that doesn't, that wants to know the answer. I know you're messing with me. I know you know, right? That it's a rhetorical answer to a rhetorical question. But you're all good, man. You're all good. It's good. It's good interaction. So when I export all of these plots, I always export the edge cuts so that we have a binding box, right? So you'll notice that we've got, if I turn the edge cuts off, so if I disable the plot, you'll notice that we've got this leading edge here of the trace and the fill over here on the right-hand side. If I was to say, I don't know, let's have a look at our solder mask. Okay, so there's our mask. The leading edge of these holes is different to our traces. So when we try to center this in our CAD program, there is no center, right? So the edge cuts layer enables us to have a XY center point that we can flip around, and everything gets aligned to the binding box of the edge cuts. That way you put the center of the edge cuts in the center or a given place, or the origin of the edge cuts, whatever mechanism you use, right? You can consistently apply that to each of your layers, meaning when you go to expose them, if I take that board off the printer, right, that we're exposing right now, if I take it off there, mess with it, then I want to expose the solder mask. I'm not going to be able to register that properly, and the solder mask isn't going to be over the pads where I want it to be. It's going to be in a completely different place, and it's going to be completely wasted, right? So the edge cuts give me that consistent form factor that we can align perfectly every single time, and that's a headache that I no longer need to have to worry about. You align it once, forget, done. It's a little bit like a two-sided job on a CNC machine, where the first thing that you do is you find the center line that you're going to flip the job on, and then you orientate a series of locator pins around that center point, and you mirror those into a wasteboard, and you drop pins in, and then you align your job onto those pins. So then when you pick it up and flip it over, it's perfectly aligned. So ultimately, this is the virtual way of doing that. All right, let's have a look at how long we've got left on this job. We're almost all the way through, so I've waffled for a bit. We're 97% the way through. We've probably got around about 30 seconds. That was actually really good timing. That was really good timing. So we're going to have around about 18 minutes worth of exposure time on the circuit board, and with any luck, keep everything crossed. Okay, spam in chat. Do you think this is going to work? And if you don't think it's going to work, I want you to say whether or not you think this is going to be underexposed or overexposed. What do we think? What do we think? Place your bets. Okay, that is complete. That is complete. Let's have a look. Rainbow running race. Okay, I've got the circuit board here. What do you guys think? Do you think this has worked, or do you think that it has under or overexposed? I'm going to give you. I went to look at my watch, but because of the chemicals, I took my watch off. So yeah, what do you think? I'm going to give you 20 seconds to respond, and hopefully that's long enough for the chat delay. You think it's perfect? You think it's perfect? Well, there's no such thing as perfect, right? Is there? There is no such thing as perfect. Okay. Let's get the camera set up for the gratuitous close-up. All right. So here we go. Here we go. So first the overhead. That's actually looking relatively promising, if I'm honest. Try and get a decent contrast on this. This is like so reflective. Come on. Where's that? That's an okay sort of. There you go. Look at that. All right, so now we've got to put it into a bath. I think it's borax based. That's what I think it is. But I've got some household detergent here that is intended for laundry that we use to develop the exposed layers. So let me just pop this back on charge just to make sure we're good on that front. So I need a container. Oh my word! Here we go. Here we go. This is Steve Waffles. Welcome in. You come in at a really good time because we're about to find out whether or not the exposure of my circuit board is successful or not. Was 18 minutes the sweet spot? Or was it under or over? We're about to find out. We're about to find out. So we're going to use. So Wilco is a high street store. I don't know if Wilco still exists. I think it's gone bust actually. But this is some Wilco Oxy Plus stain remover. Just add one scoop in every watch. So yeah, this is a oxy bleach type detergent, and we're just going to drop that in, and we're just going to let that dissolve. You live a little, you're not that far away from a large borax place. Nice. Next is using the pick and place machine that places two items on the PCB. That might be a little bit overkill. You think? You think that's proper usage? Oh wow. All right. So I'm just going to dissolve. I'm just going to dissolve this into the water, and in fact, I'm just going to add a bit more water because I don't want to be too strong. Now, I can see some imperfections in the application of the UV coating, which, if we get a successful exposure, I'm not gonna attempt to expose this again. Okay, so what we will do is we will mitigate, we will patch any places where it's not exposed properly or not protected the copper properly, on the basis that we can bodge it. I remember in school. Is this just me, or has anyone else had this experience? Has anybody been in college, high school, where you've had to make circuit boards and you've been given a piece of copper-clad board and a marker pen, and you've drawn the traces by hand? I've done that. Why sodium percarbonate? Is that what it is? Is that sodium percarbonate? I can't even say it. Is that what you think that is? Good idea. I did some research, and I am aware that is the ingredients in this stain remover are exactly the ingredients that the exact ingredients that I require to dissolve the unexposed UV coating. You guys went to Twitch? Yeah, right? You've had to use nail polish, but you've also had to use cardboard. That's pretty cool. That's pretty sweet. So I've got access to a plotter, I've got laser cutters, and I've got also all manner of different like machines at my disposal. And it's always cool to try and figure out new ways of doing things, which is why I'm experimenting with this method. When it was showcased in Stephen Hall's video, I should really get the video link to that and put that in the description. In fact, I'm going to, now I said it. So Stephen Hall's does it with a Formlabs machine. And ever since I saw that, I just thought, man, the resolution that you can get to with that, you can get surface mount, you can get all sorts, right? So, and I mean, like I say, anything for a multi-board run, you're not going to do this at home, right? Not unless you're on a time crunch and you need to confirm a board layout before it goes out, right, to a board manufacturer. Typically, you're going to use a board manufacturer to get this stuff done, right? If you've got any sense, that's the way you're going to go. But as I say, I've only got one board. Now, that's interesting. I don't know if you know this. I've actually torn up that piece of unexposed material, right? But the exposed material has stuck pretty hard to the board. That's interesting. Hopefully that is a sign of things to come, right? So, okay, so here we go. We're going to drop this in. I should really get the... I really should get this camera so I can bring you in close and you can watch the process of this stuff dissolving and find out whether or not, once and for all, did I over or under expose or perfectly expose this circuit board. This is going to be interesting. Now I can already see, can you see the changing color? Can you guys make that out? So there's a changing color of the unexposed area. That's pretty cool to see. Now we want all of this unexposed area to turn copper. And that's including all of these little traces in here. Now they're turning like a light violet color. Let me get in there and use my finger to scrub this so I can just speed this process up a little bit. But I'm encouraged by what I am seeing. This is looking good. Right, two ticks. I've got my fingers in chemicals. Let me have a look at the chat here a minute. There's some chat going on there. Borax powder is white powdery substance, also known as sodium bicarbonate, sodium, yeah, whatever. Fun fact, watched one of the shuttle land here when you were a lad. Nice. Oh, so that's one thing. That's one thing that I would. You do it! You do it! What's happening, buddy? Welcome in. Welcome in. How you doing? What board manufacturers do I recommend? So there's a couple right there. There's three that four that I've used. No, three I've used. The fourth I'm aware of. So there's PCB. I've not used those guys. There's JLC PCB. I've used them, and I'm pretty happy with their quality. I've used PCBX. Again, I'm happy with their quality. And the last one is Next PCB. And again, the three that I've used, I'm happy with all of the quality that I've received from those suppliers. Now, depending on where you are in the world, you know, you may or may not have import problems from these companies because the vast majority of them are located in China. So I'm doing good, you do it. I'm doing good. Thank you so much for asking. And how are you, man? How's Mrs. You do it? Hope everybody is well with you, man. Right. We're not supposed to be out saying, yeah, I am happy to talk about circuit board manufacturers, if I'm brutally honest. Ideally, I would like a board manufacturer for the channel, to sponsor the channel. Will that ever happen? I don't know. I am a micro, what is it? Pico. Micro, nano, pico. I'm a pico influencer. I'm a Pikachu. I'm a Pico influencer. But yeah, awesome. Relax in the gym? You relax in the gym? You've got to be doing it wrong if you're relaxing in the gym. Okay, so I am uncertain whether or not we have isolation properly. So I'm going to clean this up with, actually, let's dunk this in some water a second. Just give it a rinse. Give it a rinsey rinse. Okay, so I'm reasonably happy with the expose. The copper clad on the outsides has come up, right? So let's clean this. Let's dry this board off. Oh, righty. Okay, let's show you what we got. So yeah, we're looking okay. I think the exposure is okay. I guess we're gonna have to dump this into some acid and etch away the copper. to find out for sure, aren't we? We're actually going to get to the acid stage of the stream. Acid! You got to watch guy that does the boards. I've had a couple of contacts. I've had a couple of contacts come in from the various different board manufacturers, and I mean, okay, so for anyone who's in the content creation, you probably already know a lot of brand deals are done seasonally. That you're unlikely to get a brand deal or significant ad spend in like January, February, March, because everyone's all spent out from Christmas. You're looking probably mid to late March onwards for that to start picking up. And I don't know, would you agree with that? I think that's my expectation. But yeah. So yeah, that's the board. That's the breakout board. We're gonna attempt to etch this and see whether or not we got isolation or not. We're gonna full send this. YOLO. Right, I just realized I am down one container, so I do need to get a container for the next stage of this process. I think what I'm also going to do, I know I just dried that circuit board, but I'm going to take that downstairs and I am going to give that a full rinse under some water. And what did that just drip on? Oh, it's okay. Just to make sure there isn't any chemicals on the surface of this board. Going to wash it thoroughly rather than just that doodad, right? Okay. Using Steve PCB for your next batch. Right? Okay, give me 2 ticks. In fact, for amongst yourselves, I'm gonna take you on a journey, because I'm gonna leave my mic hot as I go, and hopefully you can hear me the whole way, so I can narrate as I'm away from the. Oh yeah, there's definitely something on the surface of this board. It's got like a slick surface when you make it wet, and you don't particularly want that. So a good rinsing with water. I might even do an IPA sort of wash as well. I bet this sounds really strange. I know I got noise cancelling on, so I don't know how much of this running water commentary you guys can hear. But yeah, I'm definitely rinsing a circuit board, guys. I'm not doing anything else. Okay, keep it family friendly, please. Keep it family friendly. And I can't see chat, by the way, so I am narrating blind, completely and utterly blind. So now I'm going to go and get a paper towel and just dry this off. Surface still feels a little slick, but yeah. It'd be interesting to know how far my audio works. And you guys tell me in chat whether or not you can hear me the whole way through. Okay, so I need a plastic container that is never going to see the light of day again. That will do, one of them, because we're about to use some nasty chemicals to eat away at the copper. So the most common, there's various different chemicals that you can use, but by far the most ubiquitous or easily accessible material is ferric chloride. And ferric chloride is absolutely stinking horrible. I just hate this stuff. It stains. It's just horrid. It's just horrid. So the first thing we're going to do is we're going to glove up. How far did my audio go, by the way? Your chat hasn't told you, are you going to the bathroom here? I totally don't go to the bathroom on stream, right? That's a before and after activity. I mean, I know that Sushi Dragon on Twitch. If you don't know who Sushi Dragon is, you should go and check him out on Twitch. He's a live action performer, and he builds all his own tech and live stream integration hardware. And he's a pretty smart dude, to be fair to the guy. But yeah, it's he's just. The experience of watching him is a little bit like what I must imagine taking illicit substances must be like. But anyway, I digress. Right, so we're gloving up because we're about to use ferric chloride. This part of the stream, I just want to say, please do your own research around the use and disposal of ferric chloride for your region. Some places are pretty hot on disposal. However, ferric chloride can be reused multiple times. It's not like a one thing when you get rid of. But yeah, don't tip it down the drain. Don't dispose of it properly. Please act responsibly. I cannot be held responsible for your actions. Please consider this your warning. Anyway, with that said, this is ferric chloride from Energy Chemicals. And essentially all you do with this stuff is you pour it. Oh, is a plastic stopper that we got to remove. Oh, here we go. This is the bit where I spray ferric chloride everywhere and just ruin all my tech and my workspace at the same time. So yeah, it's like this yellowy substance, and if you get that on you, one thing is bad for your skin, right? That's the first thing that I need to say about it. The second thing I need to say about it is it stains. So we're going to put in as little of the ferric chloride into this container as possible, because that limits the amount that I can spill. And let's put this somewhere I'm not going to kick over, because I'm a bit of an idiot when it comes to this sort of stuff, right? So careful when you pop the top, right? Yeah, tell me about it. Well, here we go. Let's just get you over onto this camera. And let's get you guys set up so you can see a little bit better. All the better for watching, huh? Okay. So let's drop that into the acid. There's no going back now, guys. We are full send. We are full send. Now I need, right, we're going to use a Q-tip just to pokey that in and get the acid to start coating that area. So what I'm hoping is that there's sufficient protection for the traces, and that we have sufficient areas exposed to isolate the traces. So I'm just going to rock this backwards and forwards. You guys can't really see that, can you? Okay, so I'm literally just going to rock this backwards and forwards just to agitate the surface. I mean, if you can warm the ferric chloride up, typically that's better. It will speed the process up. So chemistry's so easy now, you don't have to make the stuff anymore. You can just order it on the internet, right? Yeah, exactly. You used to have to buy the crystals and mix it up yourself. Okay, let me just lift this up and see where we're at with the copper on the outside. Okay, it's going a funny color. It is, I don't know, can you guys make that out? Can you see that the copper is going a different shade? Let's get that back and submerged. And you can see like black traces, like ink coming off as the copper gets eaten away. But as I say, this is not nice stuff. This is, goes without saying, right? There's a reason I'm wearing gloves. I'm not the most safety conscious of people at the best of times, so the fact that I'm wearing gloves should tell you everything that you need to know. I think it was a good old mix of steel wool, hydrogen peroxide, and hydrochloric acid. Nice. Sounds yummy. Don't drink. Don't. Not if you want to die. It's like, seriously. That's bad. Okay, so literally just going to rock this backwards and forwards, agitate the surface so that the copper that's dissolved into solution moves away from the fresh pieces of copper underneath. And I'm concerned that we're actually overexposed again. I'm concerned that the copper traces separating the ground plane, they're not going to etch because they look just as bright as they did when this went in, where the surround is not so much. Trust in the process, Steve. Trust in the process. One thing we probably will be able to do once we've etched this completely is to hold it up to one of the studio lights here and see whether or not we can see the light coming through the FR4 board where the copper used to be. You see it on the gloves? Look at that. Nasty. It's nasty stuff. So should this fail this time around, what I'm going to do is I am going to modify the circuit board and I'm going to remove the ground plane fill. I guess to some extent I wanted to reduce the amount of work that the ferric chloride was doing. And in doing so, I may have ended up making this more difficult for myself. From the camera, it did look like there was still a thin layer of exposed film of copper traces. On or in between the copper traces. So the plastic film was removed. Okay, we're starting to see the copper is almost gone on the perimeter. So we need to wait and see whether or not that actually gets the traces isolated. Oh man, I don't think it's going to. Sound off in chat. What do you reckon? Do you think this is going to work or do you think this is going to fail? I don't know, actually. I think it might be slightly over. So on the upside, I'll be able to, if it is over and the copper slab hasn't been exposed enough. Sorry, the copper slab hasn't been eaten by the acid. One of the things I will be able to do is to recoat this, put it back in the machine, and re-expose it because of my registration. Okay, well, let's do an inspection. So let's pick up the board. Let's let all the nasty goop go away. Now I can see light through the board from where the surround was. So what I'm going to do now, I'm unable to move the camera or touch anything right now because I've got ferric chloride potentially dripping everywhere. So I'm just going to drop this in a water bath just to get rid of any ferric chloride on the surface. And we're going to have a look. Did we do a number on this? Or did it do a number on us? Okay, let's put that there. I need a paper towel to dry this off, and then I'll sort the camera angle out. This is where I need a stream producer that can remotely change the angles of my stream, and or be able to get you guys a decent look. Right, okay. So there's the big studio light. And it would seem that we do not have ingress onto the copper of the copper traces. So we're overexposed. Damn it. Okay, so we are overexposed. So the copper's gone here. The copper's gone here. But the traces, the trace separation, it's over. So that was 20 minutes. So that was 18 minutes. That's irritating. That is so dang irritating. So, question for you guys. Let's put this ferric chloride out of the way a moment. I will have to move it again, but let's bring in the caustic soda. And we're going to get rid of our mask. This is not the ideal situation, having to move these containers around. I wish I could just place this down in one spot, right? So here we go. Let's get the camera here, and let's drop this in, and then we'll see that coating come off, and we'll see the state of the copper. So because we've registered this, it means that we can treat this the plate again with some UV sensitive material, and then that should we should be able to expose it over the slab. You're going to see that all crinkle up in a second, like we did earlier at the beginning of the stream. So that's irritating. Oh, damn it. Okay, so we're close. So how long do we think we need to expose this for then? If that was 18 minutes, I think 15 minutes was under, 18 minutes is over, 16, 17 minutes. Here it goes. I guess it's got to work a little bit harder this time round because there's acid on the board. So it's got to neutralize the acid first and then take it to a base, get it to maybe warm the bath up first. Which bath? The acid? I mean, the acid works really well. It's the exposure. Here it comes. It's going to be interesting to see what this looks like. So that copper slab. That copper slab is pristine. Oh boy, seriously? Yeah, I mean, the fact that we were able to remove the traces, the copper here, right? It tells me that the method that we're using to expose and develop the the material, the UV material, is absolutely fine. Yeah, I don't think. I mean, I don't have that chemical, right? So sodium percarbonate after exposure wash. I don't know what that is. And I don't know the layman's, like, you know, I don't know a product that has that in because I don't recognize the ingredient itself, right? But looking at this copper slab, it is pretty much intact. So I'm going to go, like we did yesterday, I'm going to go one more round. I'm going to go one more round and see whether or not we can get this to expose. I'm going to go and just rinse this off. I'm not giving it a water drench, but I just want to make sure there's no caustic or acid on it before we start playing with it again. I've been sick. Name the movie. If you get that one, you get bonus points because that's so random. I'd be very surprised if anybody gets that. OxyClean, any type of OxyClean. Oh, that's what that is. That's so that bath that we did, that is an OxyClean product. So it must have that in it then, right? Okay. I should be able to do this now because my hands are clean enough to touch the mouse. Rootsman, there's meese, I beat this house. Yeah, that's over. That's overexposed. I wonder whether 15 minutes is actually the sweet spot. What do we reckon? 15 minutes is the sweet spot. Right, let's get the laminator warming up because that's going to delay us. So let's get ahead of the game on that. I'm going to get a fresh piece of towel. And we're going to use isopropyl alcohol again. And we're just going to wash this down. We are so close. We are so close to this. It's not funny. It's so close, it's not funny at all. Right, so I've got a registration mark on the bottom of my board, so I know which way to put this in the machine so that we can use this, you know, this copper clad board. It's actually going to be a good test to see how good our registration is as well, which will help us further on down the line when it comes to doing the solder mask. The solder mask process will require us to have decent registration. It can be off by a teeny tiny bit, but I mean, this is going to be the proof is in the eating, son. Right. Oh, okay. What's this, like the 18th time? No, it's not the 18th time I've done this. I'm only kidding. But it's not the first time either. Okay, so let's go here. Scalpel, matron. Righty. Let's get this away into the bag. I don't know why there's areas of this thing that's been exposed because it's been in this bag the whole time. So, and it was originally in a drawer. And mind you, it is a clear drawer, so there's opportunity, right? But I'm gonna take these gloves off because just need to make sure I don't touch the surface of that. Because I don't want to get finger grease on there. But I don't want to fight with tape stuck to the gloves. Right. So, as I stated before, if you're new, we are using a UV coating to apply to a copper clad board, and it's inside a sandwich. There's a clear coating on both sides, and inside is a UV sensitive material that we are now going to get stuck to this copper clad board. So we do that with two pieces of tape touching each other on one of the corners, and then we peel away and it will remove one side of the protective coating. And we then lay the resulting side down, face down, onto the copper clad board. And I've got an incoming phone call, which is always good. Right, give me 1 sec, guys. I'm just going to mute while I take this call. The wonders of being your home's IT support. It's funny because it's true. Okay, there's bubbles. There's bubbles. Bubbles are the enemy. Bubbles are the enemy. So we want this to be as bubble-free as possible. Okay. And now I'm going to cut off that piece of tape because I don't want that sticking to the paper that we're about to use to bond this material. I expect you to stick, Mr. Bond. Yeah, we don't want that to bond to the paper. Right, okay. So here we go. Piece of fresh copy paper. As a little envelope. Sorry if I'm repeating myself. I know I'm repeating myself a little bit to those who have been around this a little while, so apologies ahead of time. But anyway, so we place this inside the paper, we close it up like so, making sure everything's nice and flat. And I always keep the fold to the edge, 90-degree angle to the way I'm feeding, so that the paper doesn't ripple the surface of the circuit board and cause us all sorts of like problems with the bonding process, right? So we said yesterday that this was going to be a one-pass job, so let's go a single pass. Oh, we'll get there. We'll get there. And then what we'll do, we'll load this up into the machine. We'll output the file, or refactor what the file is going to be, and then, yeah, we'll go from there. So how many minutes do we think we want this to be? Do we think 15? 15 failed yesterday, and it was it dissolved. So I don't know why 15 worked and 18 didn't. 18 was over, so we're like right on the cusp of it. But equally, we are getting into the roll, so it could be that we're at a part of the roll of the UV sensitive material that is in better condition than the outer layers. So that could very well be playing a part, thinking about that. So maybe we go 15. Let's go 15, and then we will see if that works, then we're good. But if it doesn't, we can put it back in for a little bit longer if need be. Okay, we now have a coated board. Ta-da! Right. Okay, so this is how I work out the duration. I've got to find my registration so that this copper clad is the bit that gets exposed. So I did say I was going to end up having to move that vat of... I was going to have to move the vat of... ferric chloride. Did that just tear up? It blinking well did. Not too worried about that because that's already etched away. Okay, so I'm going to pop that into the machine, get it registered. Bish bash bosh. Oh, that's not good. That's bouncing. Why is that bouncing? Because there is an excess tab of material on the bottom. Gone. Gone! All right. Okay. So let us put that into the machine and orientate it. Perfect. Job done. Winner, winner, chicken dinner. All right, we're moving a pot of ferric chloride and hopefully not spilling it or getting any of it on me, because it's horrible. It's horrible. It's horrible stuff. Right, okay. While we are prepping, let's get our file ready. And this is the calculations that I use in order to get the duration. So I am operating at a 0.05 millimeter layer height. Each layer height is 15 seconds. So I want a 15-minute exposure. So I am absolutely poop at math in my head. So let's get a calculator up. All right. So the way that I work this out is like this. So 15 minutes, if I convert that into seconds, we multiply that by 60. Okay, and that gives us 900 seconds. Okay, so now I need to figure out how many layers that I need in order to get a 15-minute overall exposure. Now we know that each layer is 15 seconds. So we divide 900 by 15 to get the layer count. Okay, so it's 60 layers that we require in order to get a 15-minute exposure. Okay, so in order to get a 15-minute exposure, we need 60 layers at 0.05 millimeters. So we multiply 60 by 0.05, and that gives me a 3 millimeter height model. So let's open up Fusion 360, and we're going to input the model to a 3 millimeter height, a 3 millimeter STL file, effectively. Okay, I need the pen drive. And I need to open up my breakout file, and then let's bring this down. Yeah, you could probably do that. That would probably work. I think what you would need to do is to make sure that you so you would need to use double-sided tape or some way of putting the copper-clad board onto the plate, and then you'd need to zero the plate out at the bottom of the resin bath, on the screen, like you would level out your bed normally. That would probably work, but you probably need maybe 3 layers. I would probably go 3 layers worth of resin. But then how do you get the resin off after the fact? That could be kind of tricky. Well, I'm going to speed run this, right? Because normally what I would do is actually adjust the height of the extrusion. I'm not going to do that in this case because this may or may not work. I'm going to try it. I'm just going to go into the root of my drawing. I'm going to stick a construction plane on the top of the surface. I know this is 3.6 millimeters tall. So what I'm going to do is I'm going to create a sketch on that construction plane. And I'm going to do an all-encompassing rectangle, like so. Finish the sketch. I'm going to select this. And then I'm going to extrude, and I'm going to go by -0.6 because I know my model is 3.6 millimeters tall. Now it's going to go, because of the geometry that exists, it's going to take a second. It was quicker than I thought it was going to be. So that is good. Spoke too soon. Okay, I've just clicked OK, and then I'll just do a quick inspect. I'll use the inspect tool. The problem was the lack of symmetry. No, it's the vertice count. The output was like incredibly vertice heavy. Right, so I'm going to inspect the top layer with the bottom layer. And it's going to tell me how thick it is. That should be 3 millimeters, which it is. I don't know if you can see there. It's 3 millimeters. Perfect. Right, okay. So what I'm going to do now is right click. We're going to save as mesh. We're going to click on OK. We're going to go board test 2, and I'm going to change that to board test number 3. Hit return and click save. Perfect. Now I'm going to open up the Lychee slicer, which is the slicer of choice for me for my resin printer. Ay, ay, ay. Okay, we're going to decline the recovery. We're going to add files. We're going to select the board test number 3. We're going to click on open. Okay, the next thing we're going to do is we're going to flip it. So on plane and flip. And now we go to export. Let me just double check the settings here that I put in. So we've got one layer, a burn-in layer at 15. The rest is 15 seconds. Light off delay is 2 seconds. We don't want it to move up or down at all, blah, 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 blah. And then we just click on OK. And now let's anti-aliasing. We're going to sharpen the detail. We want it as clear as possible. And now we need to plug in our pen drive. In goes the pen drive. Okay, let's close that window. Exports. Now we get our obligatory 20-second ad because I'm using the free version of Lychee Slicer. Lychee Slicer is actually pretty good if you're into printing minis. When you, I think it's a subscription model, so it's a bit of a SaaS solution, as a lot of software is going these days. But at least with Lychee Slicer, you have a lot of access to a library of models that you can download. So if you're into D&D and things like that, it's like unlimited type of characters that you can print for your D&D escapades, right? So when you mess with symmetry, the symmetry gods start playing games with you and cut other processes. Yeah, true that. True that. Okay, so we're going to say board test number 5. And we're hoping this is going to be the sweet spot, right? We're hoping. Fingers crossed. Okay, so that's going to take 17 minutes because we've got to remember we've got a 2-second off delay in between each layer just to give that LED light source a bit of time to cool down rather than running it permanently, which, you know, kind of sucks. Right, so before I run this blind, what I'm going to do is I'm going to run this without the board on. I want to see the I want to see the file. Is that number 5? I can't read. No, it's not. For some reason, it's jumped to the very top of the list. It's like, thanks. Okay. So I'm going to run it with nothing in. And then I'm going to just confirm that the orientation of everything is correct. Because that's the last thing I want. You should be able to get UV resin off with acetone. I might experiment with that. But then you've got to get all the resin off the board. Okay, down you go. Turn it on. There should be a square thing over here. And yes, there is a square pad. Let's turn that off. Cancel it. Okay, let's put our board in and orientate it. In fact, I probably need a lint-free cloth just to give that screen a little bit of a wipe. There's a bit of dust on it, and I don't want that to be an artifact. Okay, 15 or 17 minutes to go. Here we go. This will be the last test of the night. And fingers crossed this will result in a circuit board that we can actually use, right? You've got 70 minutes to experiment. What? Experiment with... I could probably tell you about a couple of projects that I've got in the pipeline. So I've got some streaming hardware that I'm currently prototyping. And I'm looking to bring out a suite of live streaming tools, physical live streaming tools that hopefully will people will find useful. One of which is my streaming controller. So this is probably the first time I've filmed this on YouTube, right? But this is my live streaming controller, and I live stream at Maker Central, which is a UK maker convention, and essentially I can control my live stream from the con using this. So this is getting a complete makeover, right? This is going to be one of the products that I'm going to be making. And essentially it's batteries coming out. Don't. You can detach it, potentially put it on a base. This is just a like a jig, right? And those of you who have seen me on Twitch have seen this before, right? So this is not new to you, but this is the first time showing it on YouTube, right? So that's one of the projects that I'll be revising and doing a complete overhaul. So yeah, there's that. There's a couple of other bits and pieces I've got in the pipeline. This prototyping work that we're doing here for the circuit board. That may well make it to YouTube. I'll do my best to get that. Don't particularly want to call it an NDA, but that's kind of what it is. So yeah, see if I can get that lifted, and I can then talk freely about that particular type of product. I remember the Twitch days, right? So I was live streamed on Twitch from about 2016. So this isn't my first rodeo into the live streaming arena. This is the first time that I've been live streaming on YouTube. For there's been spotty like live streams previously, but I'm going to be probably starting to do more regular live streams, hopefully demonstrating things that we can turn into some content for the channel. So yeah, bigger and better things are coming. Bigger and better things are coming. You had more hair back then, right? Yeah. Oh, don't. I've got that harp sound, right? And the dream scene kicking in as I transport myself back to that time. Oh my word! So yeah, I do want to do some new electronics projects. I want to revise some of the old electronics projects and get those completed. I'm going to be showcasing different materials, different machinery. So one of my good friends, he's got access to, I think I mentioned on yesterday's live stream, he's got access to fiber lasers, CO2 lasers, RF lasers. The one laser he's got will cut up to 80 millimeters mild steel. So, you know, with some collaboration with him, we can probably bring some pretty cool content to the channel. So yeah, that'd be kind of cool just to do. Let alone it's really cool for me, let alone for you guys. You know, hopefully you guys find it cool as well. But I guess I'm being completely selfish at that point. But okay, so that's wearing away. So any of you guys in chat got any questions about the overall process that we're trying to use here for making this circuit board? Feel free to ask questions along the way. More than happy to get into that. All right. That's right. Just had a notification on my screen then that really freaked me out. Just thought, what does that mean? So I just had to check we were still live. Everything looks green on my side, so hopefully I'm still here. So while we wait for this to expose, I see how long is actually on the clock right now, because now we've got a series of layers in here. It should give us. So we're on layer 14 of 60. So it's going to take a while. It's going to take a while, but it will come. It will come. So is there a particular project that you guys would like me to take on? Is there a particular topic that you would like me to get into and demonstrate? Or is there something that you would like to challenge me with to see whether or not it's something that I can figure out and make work? So if there's something that you're working on that you've got questions or queries about, feel free to ask in the chat. That is absolutely okay. That's why I do this, is to share my passion and hopefully help people along the way. Anyways, how is that PCB working out for you? Has that gone into production? Just make a space rocket. Hang on, then. Hang on. You'll have to bear with me. I might be able to. I might be able to do that. I might not. How's that? Is that any good? I mean, it's not too bad for like short notice of washing up liquid bottle and some sticky back plastic, right? So. That's so funny. That's so funny. So yeah, like I say, I'm going to be doing a lot more of these live streams, hopefully featuring the Lumen PMP, featuring business end projects. So I'm probably gonna be asking out on social media for you guys to feedback to me. And if you're watching the VOD and you've got this far, first of all, thank you. Secondly, what would you like to see on the channel, generally speaking, and what would you like? What questions would you like answered? Pop in the comments below. This will be going out straight into a VOD at the end of the stream, so hence the call out to put some chats or comments in. Okay, how are we doing over here? Okay, we're 20 layers in. So just a little over, we're now on 21, so we're a little over a third over. Yeah, a little way, a third over the. See, this is the boring bit, waiting for stuff. This is when you wish you could time lapse real life. And unfortunately, you can't. So how many of you guys use Fusion 360? No, you didn't. Did it? How did it come out? Did you have you actually used it? I'm keen to know. Are you guys? I don't know what the chat delay is on here, because that was a question asked a little while back. So yeah, if you use Fusion 360, I think one of the things I'm probably going to be doing is some Fusion 360 tutorials. So I might ask in the community tab for some feedback around the workflow that you want me to like go over. I have recently started working in the sheet metal workflow of Fusion 360, which, in all honesty, I probably wouldn't. I would demonstrate me using it rather than say, here's how to do it well. But from a 3D modeling perspective for 3D printing, from a assembly point of view, from a CNC point of view, you know, I would consider myself a competent user. Here's one of the things I'm working on that I will be bringing to the channel, and I've got a video on how I made this. I do have to carve out some time. My life is incredibly busy, so until the magic formula happens and I go full time on YouTube, which is, you know, until it happens is a pipe dream. Trying to dedicate time to things, real life, my day job, the projects, the sort of ambitions I've got for the YouTube channel. You know, it's patience. Got to exercise patience. But one of the things I'm making is a jazz-based guitar for my youngest son, and this is a CNC test of the body of the jazz-based guitar. So this was made on a restored CNC machine, and yeah, you'll find there's a common theme. I get gifted broken machines because they were going in the trash, and I repair them and make them work. I wouldn't necessarily say I repair them fully, but I get them to an operational state where I can actually use them, and I learn about these machines while I'm at it. So yeah, this is made out of twine and some OSB. There's some OSB Go Faster stripes. This is just a blank that I put together to test my CNC toolpaths, to see whether or not the base was in good shape from a CNC perspective. So, like I say, I'd like to do some tutorials on Fusion 360 for beginners, ranging from sort of the entry level to intermediate and more advanced techniques, certainly from the personal license perspective. There's obviously features that I can't demonstrate from the paid-for license because I don't currently have a paid-for license. And if I go into production for certain things, then I'm going to need to get one of those. Otherwise, Fusion is not going to be very happy with me, or Autodesk is not going to be very happy with me. So yeah, maybe I can reach out to them, see if they'll be a channel sponsor. That would be nice. That would be worth it, right? So I don't want to sound like I'm a fanboy of Autodesk, because there's certain things about Autodesk I'm not particularly happy about in terms of the way they handle the transition to the current licensing model. They kind of alienated a lot of the makers in the way that they've done that. And there's a video on the channel talking about that. But what I've found is that Fusion 360's UI is in tune with the way my brain works, in the way that so I can go into the sketch workflow, I can design something out, and I can 3D model things up relatively quickly. So in that regard, you know, that's why I keep gravitating back to Fusion 360 when I've tried other applications which are very capable in their own right. So you've got, on the open source side of things, you've got FreeCAD, very capable piece of software. In fact, the Lumen PMP core files are in FreeCAD. So I used FreeCAD in order to export and get all of the 3D models to make the source version of the Lumen PMP that I made. But the UI I find very clunky, and you've got to do mental gymnastics to make it do what you want it to, where Fusion, I hate to say it, just does it. I mean, I would love to support the open source community more. But in terms of ease of use and the time that I've got available, then, you know, it's a little bit more tricky. Alibri, on the other hand, which is a paid option, it's a lifetime license for Alibri. Atom 3D is the hobbyist intermediate sort of application. That's more than capable. But again, I gravitate back to Fusion 360 because I'm comfortable with the UI. And you know, I've used it for so long now, it feels like that old chair, right? That's kind of torn, tired, but you sit in it and it just fits. It's comfortable. You know, it's a welcome feeling, right? I don't feel alienated in Fusion 360. It is, unless they do an update and they move things. One of the comments on a recent video was that they'd moved some of the mesh tools, like for VNA. I assumed it was to do with converting STL files to a solid body where you could start modeling against it, etc. But it's moved to the mesh section within Fusion 360. It's not gone; they just moved it. So yeah, they did the Windows thing where they completely changed the UI. You know, Office 2003 to 2007, I think it was, when they introduced the ribbon and changed all of it. It's like, I knew how it worked before, and now I feel like a complete idiot because I can't find nothing. So, yeah, story of my life. Anyway, I'm rambling somewhat. So we're waiting on the exposure of this circuit board. But if I can do if there's any content that you wanted to see around Fusion 360, I'm more than happy to entertain putting that sort of stuff together for the channel. And I need to start ramping up my content production. And live streaming is part of that. Live streaming is part of my strategy. So let's have a look. So Fusion 360 is like a Secret Labs chair. Expensive, but good. Listen, I didn't buy the Secret Labs chair. I was quite happy to sit on the old crumbly chair, right? But the wife came up the other once, saw the state of the chair, and she was like, So she bought me the chair. So what can I say? Right, how far in are we? We're 45 layers out of 60, so we're not that far away now. We're closing in on. We're getting into the closing stages of this. Okay. So Gary T, what do you use? You use Fusion 360 quite often. What do you use it for predominantly? That was one of the things that I gravitated towards Fusion 360 was I learned one application that I could drive all of the workflows because at the time when I first started using Fusion, I was only doing 3D printing, but I knew the direction of travel I was going in was I was likely to get a laser cutter, and the CNC was just a like out of reach sort of bucket list item. But I knew that Fusion 360 could drive all of those workflows, so I chose Fusion 360 on the basis that I'm learning one application that can do all of these things. I didn't have to learn 3 applications for each of the different workflows. So what do you use Fusion 360 for? Is it 3D printing, CNC, laser cutting, or something else? I'd be interested to know if anyone uses Blender for 3D printing. Blender is an absolutely amazing animation program, and I played around with it probably from about 2001, 2002-ish, if my memory serves me right. I was blown away by the fact that it had like water simulation, smoke simulation, all in like a 25 meg download. Like, it was awesome. It's probably a lot bigger now. I don't have Blender installed. I'm keen to see what the delay is on the stream, because the chat delay seems incredibly long. Anywho. Where are we at? We're at 52 layers. 52 layers. We've only got a couple of layers to go. So here's how this is going to pan out. We're going to develop this board. If I believe that this board is in good shape and worthy of attempting to etch it, that's what we're going to do. We're going to try and etch it tonight. If it is not etchable, then we're going to abort and we will come back. I'll do some experimentation and I will schedule another live stream where hopefully I will have zeroed in on the exposure levels that we need to get this to be a fire and forget exercise. That's ultimately what we want. It's a fire and forget experience. And that's far from what we're getting at the moment. We're scrabbling around in the dark. 55 of 60. We're getting close now. So just over a minute remaining on the exposure. So that's 15 minutes exposure. Let's have a sign off in chat. Do we think that that's going to be good enough? Do we think that that's going to work, or do we think it'll be underexposed this time? Or do we think we've nailed it? Oh, it'd be nice if we nailed it. So we have to, if we've nailed it on 15 minutes. When I did 15 minutes on the first live stream, it failed. It was underexposed. So the only variable that we've got here is the fact that we've gone deeper into the role of UV sensitive material, and that part of the material, because it's old, that's potentially in better condition than third time for lucky, first try. Right? Where are we at? 58. 2 layers remaining, and then we're good to go. I so hope this works. I so hope we got it this time. Okay, penultimate layer. How many of you in chat would be tempted at taking this on? Would any of you be tempted in taking this? That's it, we're done. Okay. You've got nothing better to do than watch me fail. Well, thank you very much. Right. So we've got an exposed board. Okay. Let's give this a dunk in the developer. And with any luck, we are good to go. With any luck, we will be good to go. All right. First and foremost, we have to remove the protective coating. Let's try not to throw it on the floor. Hey. So let's do that with this shot. That PL moment. Okay, in it goes. We're not fooling around now. You know what? I'm actually pretty confident this time. Looking at this, I think this may actually just blooming well work. Okay. Our registration is on point. The registration of the board and the artwork is perfect. I'm super pleased with that. Right, I tell you what I'm going to do. I'm going to be a little bit more aggressive with this. So I'm going to get a soft, stiff, but soft, bristled brush. We're going to give that a scrub. Okay. Okay, we're going to give this a decent soak in here. I wonder whether or not having warm water would be better than room temperature. That could be another variable that we've got to contend with. Do you know what? For all the sort of hope that I initially had, that has just started to fade. I think it's overexposed again. 15 minutes is overexposed it. What? So this old like material UV coating is proving a bit problematic. So I think I'm gonna give this a scrub and see whether or not we can actually get to a point where I'm comfortable with the trace separation. If I'm not comfortable with the trace separation, I'm gonna need to do some thinking about how do I get to a place where I know the yeah, that's not great. Oh man, that was looking so good as well. I've got the same toothbrush as you. Okay, I'm gonna give this every opportunity to succeed. Okay. Yeah, I'm not comfortable we got trace separation there. Ah, dang it. It should be no more than 8 minutes of exposure. That presumably means, well, that depends upon the, presumably that depends on the quality of the UV material, right? So what, you think we should try it with an 8-minute exposure time? All right, well, I tell you what I'm going to do. I'm going to leave it in here to see if we can get the remaining, because you can definitely see the trace the separation map lines between the traces. What's not happening is it's not dissolving to expose the copper. So I'm going to leave that in here. I think I might leave it in here overnight, so the exposed stuff will remain exposed. Right, but any chance of the other stuff not dissolving, it will dissolve. What I will do, if this fails to dissolve and isolate the and expose the copper traces where we want the copper to be removed, if it fails to do that, I will do some research on or experimentation off camera, off stream, to figure out what the correct exposure level is, because the variable is this. The variable is the material that I'm using. That's clear, right? Because 15 minutes on yesterday's stream at the very beginning overexposed it. Underexposed it, and it dissolved. Now it's overexposing it by the looks of it. So let's call it here, and I will schedule a stream when I know that I've got it nailed. And then I'll give everybody as much notice, probably like 24 hours notice, that we're going to have a live, and I'll announce it in my Discord server. I'll also announce it on my Instagram and my Facebook page that we're going to do it, and then hopefully I can then demonstrate what we're gonna do, right? So you're not going to be making a 6090 GPU tonight then? No. Yeah, I think you're correct. I think that's the variable. So maybe if this doesn't dissolve, I will try and expose this for 8 minutes at your suggestion, on the premise we're at good material. And then I'll expose it, develop it. If it develops okay, then I'll hold on to this and we'll get a stream up and we'll etch it. Either that, or I could, well, yeah. It would be a shame not to live stream it to get it done, but I could just etch it and do a video top and tailing the process. Whatever you guys think. Well then, guys, I'm going to call it at this point. So keep your eyes open for some notifications as to whether or not this has worked. I'll probably post in the community forum tomorrow with some pictures as to whether or not it succeeded. And until next time, have fun, be safe. I will catch you in the next one, and make something cool. Bye for now.